And this is in the j's place. Make sense? So E1 means what? The first one is 1. Rest of them 0. E2 means what? The second place 1. Rest of them 0. So it's basically a unit vector for each coordinate. Remember? In the Cartesian system. But we may not have a Cartesian system. Cartesian system is a special case of n-dimensional Euclidean space. We can have arbitrary 3 linearly independent vector to span the 3-dimensional space, correct? So if this is x, y, z, or x1, x2, x3, so here is E1, E2, and E3, correct? That makes sense? But I can also have you see what I'm saying? Any 3 independent vector to form a basis. Make sense? They don't have to be perpendicular to each other. Does that make sense? They're not Cartesian system, but they are still the basis. Yes, they're not perpendicular to each other. Any 3 independent vector will do. Does that make sense at all? So many of the system actually, especially in structure definition or vibration you guys talking about in your civil engineering domain, their system is not Cartesian system. They don't have x, y, z direction. You can convert them into that regard, but the vibration has a direction and a magnitude, correct? Did that make sense? They're not totally horizontal or vertical. You can divide the vibration into 2 Cartesian space. However, their major axis is not in line with Cartesian space. Does that make sense? And their magnitude may be not the same between x and y. So that means in your Euclidean space, the size of x and the size of y are different. You understand what I'm trying to say? Vibration is very simple. This direction vibration is bigger than the vibration in this direction. So you still have a basis, but they are not necessarily perpendicular. They're not necessarily the same size. Did I make okay with this? So it's kind of an abstract, but still, you got plenty of application using either the perpendicular space, we call it Cartesian space, and the other one. All right, so now, we start talking about x belongs to the n-dimensional Euclidean space, and S is a basis. Doesn't matter how they are. So therefore, I can represent X as a linear combination of A1 through AN, can I? That's what it means. And the J times AJ, correct, can represent as that. And this expression is unique, which means you cannot find a second way to do represent X. Okay? Everybody okay with me? So that means A1 to AN are also linearly independent. So that also means what? I'm just writing down all these equivalent statements. Okay? I'm staging for the proof, so that's why I keep writing down all kinds of. Then we're trying to say, we're going to let a vector called A prom belongs to A. En. Okay? And define a set called S prom equals to A prom, A2, A3, all the way to AN. So my conclusion is if S is linearly independent, or say S is a basis of En if only if what I mean is, let A prom belongs to En, similar to let what? X belongs to En, correct? Anything in the n-dimensional Euclidean space can be represented as a what? Linear combination of A1 to AN. If A prom is belong to AN, then it can be also represented by the linear combination of A1 to AN, correct? And lambda 1 has to be non-zero. Everybody okay? That means what? If lambda 1 is not zero, then we have a trouble. We see what happened. First, we're going to prove this direction. Assuming this is a base, okay? Then I'm trying to show lambda is not zero, lambda 1 is not zero, correct? Okay, now we're trying to reach from A implies B, okay? So if A is true, B must be true. I'm trying to prove this, but it's hard to prove. So what do? I'm using a contradiction approach. What I'm trying to do that is what? If B is not true, then A is not true. Everybody okay with me? So what I mean is, if A represents a range, okay? B represents what? Grass is wet. Everybody okay? Everybody okay? I'm trying to prove this, but here is the trouble. If the grass is wet, is that definitely has to be rain? I can sprinkle system did the job, correct? Yeah, it could be a variety of costs, correct? But if it's rain, definitely this is the conclusion. I can also prove equivalently if the grass is dry, definitely it didn't rain. Am I correct? Of course, it's definitely didn't. Nobody sprinkled the grass. Nobody do car wash, okay, and all that about. But definitely we can do. A didn't happen. So what I do is I'm using a contradiction approach. Contradiction approach, meaning I'm going to start with something called negative B. Negative B here is what? Suppose lambda 1 equals to 0. How's that? Am I okay? Very beginning, we're trying to say, this is A, this is B. So here we're trying to do, this is A, trying to prove this direction, right? And this is B. Make sense? So in order to prove contradiction, I want to say negative B. Okay? If lambda 1 equals to 0, here what I have is we must to show that, must show, which is negative 8. As prom is not a basis. That's easy. Everybody okay? Then, what does that mean? If S prom is not a basis, meaning what? A prom, A2, all the way to AN, what happened? Linearly dependent, correct? What is the definition of linearly dependent? Look at the page number 11. What is linearly dependent? And that means what? Okay? Any x belong to S prom. Correct? Can be represented as, oh, sorry, don't need this. Sigma is it mu or lambda? Lambda 1 times A prom A1 A prom equals to lambda 2 times A2 plus all the way lambda n times an. Everybody okay? Everybody okay? And this guy is not 0. So we'll be creating a contradiction. So what happened is if lambda 1 equals to 0, okay, what can we do is this guy equal to 0, this term is gone, okay? By assumption, this guy is gone. So lambda A prom equals to lambda 2 times A2 to lambda m times an. Can I move this guy to the right-hand side? Can I move this guy to the right-hand side? This guy to the right-hand side. So what do you come up with? If lambda 1 equals to 0, this term is gone, okay? Then I can have 0 equals to negative 1 times A prom plus lambda 2 times A2 plus all the way, what? Lambda n times an. Make sense? Equals to what? 0. Can you check page 11 on your slide? What does that mean? Linearly dependent, correct? Because now all lambda equals to 0. Did that make sense? Did that make sense now? And then, since I can find a set of lambda, their sum linear combination together equals to 0, but one of the lambda is not 0. Make sense? So I can conclude what? S prom is not a basis. So this is what? Negative b all the way, I'm reaching what? Negative a. Cool? Now I'm going to prove the reverse direction. The reverse direction I want to prove B to A now. True A equals to true B. Because this means if and only if. I need to prove two directions. So here what do we have? I'll start with the B, true B, which is lambda 1 not equal to 0. Correct? So we want to show that S prom is a basis. How's that? Everybody okay? So we must show that mu1 times A prime plus mu2 times A2 plus mu3 times A3 plus all the way to mu n times an equals to 0, all the mu equals to 0, correct? That's linear independencies, correct? The only way this happened is all the mu equal to 0. Page 11, correct? Make sense at all? So I'm trying to write out what is the initial condition. We assume this is not 0. Then we're going to represent what? This is the condition and has to be true. So here we have, I'm going to start writing over there. Okay? I know that before I go, lambda prime, since lambda prime belongs to En, can be represented as what? A linear combination of what? Lambda 1 times A1 plus lambda 2 times A2 plus all the way to lambda n times an. I'm going to replace the A prime in here, correct? So I'm going to do this whole thing, replace over here. Make sense? I'm going to start writing over here. U1 times lambda 1 A1 plus all the way lambda n times an. Is that okay? Then plus mu2 A2 plus all the way mu n times an equals to 0. Still okay with me? So, I'm going to collect A1, A2, A3, and all the way to an. See what happened. So here I have mu1 times why don't we do that? Lambda 1 times mu1 times A1. How's that? So I have lambda 2 times mu2 is that lambda 2 times mu1? Sorry. Can you understand what I'm trying to do? I'm collecting term. So this one will be mu1 times lambda 1 times A1. See that? This one will be mu1 times lambda 2 plus mu2. See this? Times A2. Make sense? Everybody okay? Okay. Now I'm going to use this assumption. Since lambda 1 not equal to 0 by assumption, look at the first one. What happened? Then mu1 has to be equal to 0, correct? this times this has to be 0. This one is not 0. This one has to be 0. Does that make sense? All right. Then, since mu1 equal to 0, mu1 equal to 0. See this? Mu1 equal to 0, this term equals to 0, correct? So, mu2 has to be equal to 0. And okay? Then, continue going down. Since mu1 equals to 0, then mu n has to be equal to 0. Did I actually prove this? And this is the standard so-called forward-backward method. I explain why. Forward-backward method is, in this proof, we want to do is B to A. Correct? This is what we're trying to show. But this one is okay. Lambda 1 is not equal to 0. But B, what is A? A is a basis, correct? But what does that mean? So we need to kind of backward a little bit. The equivalent of B, S prime is a basis, meaning what? This. Make sense? So this is the so-called A prime. Everybody okay? So that means A prime implies A. I cannot directly prove A, correct? Everybody okay? Then I know